the tests for 5 anions, Cambridge International GCSE Chemistry, paper 6. So here are the 5 anions: the carbonate, the sulfate, the 3 halides, chloride, bromide, iodide, the nitrate and the sulfite, as well as recognizing the positive results for or negative results for these ions using the data provided at the end of the paper. You may also be asked to describe how to carry out these tests during a planning or design question. Make sure during this lesson you complete any tasks or answer any questions by pausing the video if necessary. Let's start with the carbonate ion, CO3 2-. Does the test solution or solid contain the carbonate ion? Well, to find out, add dilute hydrochloric acid. If there are bubbles of gas, collect that gas and bubble that through a chemical solution. What is the name of that solution? Pause. Can you tell me? Okay, so that chemical solution is lime water. What is the positive result? Do you remember? It is, of course, that the lime water turns cloudy or milky. So that positive result, a cloudy solution or milky solution, tells you have carbon dioxide gas. What is the ionic equation? We've got the carbonate ion and 2 hydrogen ions coming from the acid HCl, hydrochloric acid. Can you complete that ionic equation? Pause. Come back to check and correct when you're ready. Okay, so to reveal, carbon dioxide and water. You will be expected to reproduce that ionic equation, the name of the reagent and the positive result for the carbonate ion. So testing for the sulfate ion, SO4 2-. So does the solution contain, the test solution contain the sulfate ion or not? Well, we initially add a little dilute nitric acid. That will eliminate the carbonate that we saw on the previous slide. If there's no bubbling, it's not a carbonate. So we then move on to add the key reagent, barium nitrate. The positive result for a sulfate ion is a thick white precipitate. Sulfate ions and barium ions combine to make a thick white precipitate of barium sulfate. Could you write the ionic equation for that precipitation? Pause, write the equation, come back to check. Okay, so to reveal, barium is a 2+ ion. It's in group 2. Sulfate, SO4 2-, so we just need 1 barium and 1 sulfate to give us barium sulfate, BaSO4. Note the state symbol, S. It's a precipitate, which is a solid formed by mixing 2 liquids, so that's given the symbol S. Moving on to the halide ions, so these are ions formed by the elements of group 7, the halogens, so we call them the halide ions: chloride ion, bromide ion, iodide ion. Again, a test solution. What ion does it contain? Chloride, bromide, iodide. We initially start with some dilute nitric acid to eliminate the carbonate. If there's no bubbling, we then add the key reagent, which is silver nitrate solution. You are expected to recall that, of course. And a precipitate will form. That precipitate might be white, it might be cream, it might be yellow. Do you know, recall, or can you deduce which is responsible for which precipitate? Which ion is responsible? The chloride ion, does it form a white precipitate, a cream, or a yellow? Can you attribute an ion to the coloured precipitates? Pause, see if you can recall, come back when you're ready to start. Okay, so let's just have a look. Chloride ions will give you a white precipitate. If the test solution contains chloride ions and you've added silver nitrate and you get a white precipitate, it means the test solution contained chloride ions. If you get a cream precipitate, the test solution contained bromide ions. If you get a yellow precipitate, the test solution contained iodide ions. You are expected to recall those three colours and attribute the correct ion. Chloride gives a white precipitate, bromide, cream, iodide, yellow. But what about the ionic equations? Well, let's look at one example. Silver ions are 1 positive, chloride or halide ions are 1 negative. So 1 silver and 1 chloride gives us silver chloride. Can you write the ionic equations for the formation of silver bromide and the yellow precipitate silver iodide? Pause, write the equations, come back to check or correct. Okay, so to reveal, silver is a 1 plus, bromide is a 1 minus, AgBr. There's a pattern, is there not? Silver chloride 1 to 1, silver bromide 1 to 1. If you haven't done the silver iodide ionic equation, have a go. Otherwise, I'm about to reveal silver ion and 1 iodide ion makes silver iodide. The test for the nitrate ion NO3 1 minus. The test solution, does it contain the nitrate ion or not? Well, to find out, add a strip of aluminium foil. Then to that mixture of test solution and aluminium foil, add some dilute sodium hydroxide. Heat that mixture or warm that mixture. Hold a piece of damp red litmus to the mouth of the tube. If there's a nitrate in the original test solution, then this process will generate a gas which turns red litmus blue. Pause. What gas is it? Okay, so I'm going to tell you. It's ammonia. So if ammonia is produced at the end of this process, it means you started with a nitrate ion. So the test solution contained nitrate, you've added aluminium foil, dilute sodium hydroxide, warmed it, held damp red litmus to the mouth, and it turns blue. Your conclusion, the test solution contained the nitrate ion. And finally, the sulfite ion SO3 2-. If the test solution contains the sulfite ion, we add dilute hydrochloric acid and sulfur dioxide gas would be generated. Now, sulfur dioxide gas, if bubbled through potassium manganate 7, has a distinct effect on that solution. Do you recall the original colour of potassium manganate 7 and what happens to that colour? Okay, well, I'm going to tell you. The manganate 7 solution has a distinctive purple colour, and the sulfur dioxide bubbling through it produces a change to a colourless solution. So the positive test for the sulfite is adding hydrochloric acid. It generates a gas, sulfur dioxide, which will then decolorize or turn potassium manganate 7 from purple to colorless. Could you complete the ionic equation for the reaction between sulfite and 2 hydrogen ions from hydrochloric acid? So complete this ionic equation. Pause, come back when you're ready to check and correct. Okay, so here is the correct ionic equation. SO3 2- plus H2H plus SO2, state symbol G for gas, plus water. To balance the equation, state symbol L for liquid. However, there is an alternative test for the sulfite. You just add drops of manganate 7 to the test solution and the manganate 7 will change color to colorless. The disadvantage of this, although it is very easy and convenient, is that quite a few other substances turn manganate 7 colorless. So this test will do fine in terms of GCSE, but this is probably the more accurate or chemically accurate test. Obviously, you need to practice paper 6 questions. Every second or third paper has an analysis question or a planning and design involving the anions. If you found this lesson helpful, please recommend to a friend.